So just we see some important aspects of seed production also. Isolation distance is very important in seed production of vegetables because to prevent the contamination of the varieties. So generally, the genetic purity is very much important in producing the seed. So all the plants in a variety should be same and uniform, should have same genetic constitution. So while producing the seed, we should prevent unwanted contamination from other varieties or other compatible crop species. So that we have to maintain at an isolation distance while seed production. This isolation distance is depending upon the mode of pollination. In case of chenopods and the beetroot, the pollination is done by wind. So the wind can travel long distance. So we have to maintain long isolation distance. So the highest isolation distance in chenopods is 1600 meters for foundation seed, 1000 meters for certified seed. You see for 1600 and 1000, you can see here. You can see fenugreek. Fenugreek is a self-pollinated crop, so there is a less isolation distance, 50 and 25. Potato is vegetably propagated crop. There is no chance of contamination for pollen, but there is a chance of contamination of variety from mechanical mixtures. So to avoid that mechanical mixtures, we have to maintain the minimum isolation distance of 5 meters in potato. Here also you can see chili, okra, brinjal are the often cross-pollinated crops, so the moderate isolation distance we have to follow. Tomato is self-pollinated crop, so the isolation distance is less. Pea is the highly self-pollinated crop, we discussed in the last class. So the isolation distance is very less, 20 meters and 10 meters. So there is for hybrid seed production, we have to plant the male and female plants in certain ratio. So these are the ratios for the male hybrid seed production in case of crops. So you can go through it. Seed purity. So if we take a variety seed, the variety seed should have highest purity. So the seed purity is 95% for amaranthus and carrot, 96 for wheat and palak, 99 for baby corn, okra and cucumber beets, 98 for American. Why the seed purity is very high for baby corn, okra and cucumber beets? Because of the bigger size of the seed. The baby corn seed, okra seed and cucumber seed is bigger in size. So we can easily identify the off types, other crop seeds, any emerging matter is there. We can easily identify because of the big size of the seed. So we have to maintain high genetic purity of 99% in these crops. But in case of amaranthus and carrot, the seed is very small. Amaranthus and carrot seeds are very small. It is very difficult to identify the off types, weed seeds, or other crop seeds, or emerging matter like the stones and pellets. So the genetic purity is less in case of amaranthus and carrot. The genetic purity is very high in case of baby corn, okra, cucumber beets based on the seed size. If they ask enough matter, you just you reverse it. If 99% baby corn is there, the genetic purity of baby corn is allowed 99%. So the enough matter is 1%. So the enough matter allowable enough matter percent of amaranthus is 5%. Just you 100 minus the genetic purity, you will get the percentage of the enough matter. So how we reduce the moisture content in fruits and vegetables before storage? The seeds also we have to reduce the moisture content before storage. So the optimum moisture content for various crop seeds for ordinary container and vapor-proof container I have given here. You can go through this table. So in seed production, there is one important agricultural operation is roguing. That means we have to visit the seed production fields and we have to remove the off types, weed types, diseased plants frequently to ensure good quality seed production. So the number of roguings are vary for different crops. They are for beans, amaranth, palak, depends upon the method of seed production and the duration of the seed production also. So optimum seed germination percentage. So by producing the seed, the produced seed should have the minimum germination percentage according to the seed production guidelines. We have the different germination percentages of various seeds. And tag color very important. The breeder seed is having the golden yellow tag color, and the foundation seed is having white tag color, and the certified seed is having the azure blue tag color. I have given the sowing and planting time, seed rate and seed yield of various crops. The seed rate you can take for normal commercial production of the fruit and vegetable production also. The seed rate almost same for the seed crop and for a commercial vegetable crop. The seed rate and the sowing season is same, but this is a seed yield, not the fruit, not the vegetable fruit yield. This is a seed yield. So the seed yield is different, but seed rate is almost same for the seed production and the vegetable commercial vegetable production. You can go through this table. The important ones are okra and pea. In pea, the early requires high seed rate 100 to 120 kg per hectare. Mid and late crop requires 80 to 90 kg per hectare. In case of Wakra, yeah, here in Wakra Kharif crop requires 8 to 10 kg per hectare, whereas summer crop requires 10 to 15 kg per hectare. Because there is a seed germination problem in Wakra during summer season, so we go with higher seed rate in Wakra. So this is very important. And in case of onion also, the Rabi onion requires 8 to 10 kg. If you go to the nursery and transplant the onion, it requires less seed rate, 8 to 10 kg per hectare. But if you directly sow the onion seeds, it requires high seed rate, 22.5 kg per hectare. If you plant the bulbs, it requires 15 quintal per hectare. So where there is a difference in the seed rate, no, just you go through the difference. And the age of transplanting, 3 to 4 weeks nursery for brinjal, tomato, chili, cauliflower, broccoli, and 5 to 6 week nursery for leek lettuce, parsley, and 6 to 8 week nursery for Brussels sprout, onion, and celery. So it depends. Here the seed production is slightly different in cabbage. In cabbage, root crops and onion, seed to seed method. That means we sow the seed and we harvest the seed. That is followed for the certified seed production. But in case of foundation seed production, there is an intermediate step. In case of cabbage, we sow the seed, we observe the heads for true to type, and we discard the heads that are not true to type to the variety, and we select the heads that are true to type to we allow for the foundation seed. The head to seed method is again 3 types: stump method, stump with central core, and a head intact method that you can refer in a textbook. In case of root crops and onion crops also, that seed to seed method is certified. Root to seed for foundation seed. That means in first crop we sow the seed, we harvest the roots, and we check the roots for their true to type, and we check the genetic uniformity, and we select the roots with bigger size and optimum size, and we prepare the roots. We cut the lower top 1/3 portion, and the lower 2/3 portion we will cut, and the central portion we use for planting, that to allow, and that we allow the crop to produce seed. These are called stacklings. That root to seed method, we see the stacklings. This is very important. We cut the lower 2/3 portion and the 1/3 top portion, and we leave the small root portion along with the small green color shoot, and that is called stackling. These stacklings are planted for root to seed method of seed production. The same with the bulbs. Bulbs, we examine the bulbs. We see the based on the true to type nature of the bulbs, we will select the bulbs, and those bulbs we plant again to produce the seed. So there is a difference in these 3 crops. Seed extraction in tomato, and generally seed extraction is very easy in other crops, but in tomato, seed extraction is 3 types: fermentation and alkali treatment and acidic treatment. Fermentation is long duration but safe. Long duration but safe fermentation, 24 to 72 hours fermentation. Alkali treatment with washing soda, 300 grams per 4 liter. Overnight we have to keep, and the next day we can extract the seed. But acid treatment is quick with hydrochloric acid, 75 ml per 12 kg seed. Within half an hour you can extract the seed, but seed germination is affected due to the acidic nature of the hydrochloric acid. And seed multiplication ratio. What is seed multiplication ratio? If you sow one seed, how many seeds you can harvest? That is the seed multiplication ratio. If you sow one seed of tomato, from that one seed, one tomato plant will come. From that one tomato plant, how many seeds you can harvest? That is the seed multiplication ratio. So this is the seed multiplication ratio of various crops, and you can go through it. So important diseases and vectors. So generally mosaic diseases are transmitted by whiteflies. Aphids and whiteflies, second pest. Tomato spotted wilt virus transmitted by thrips, little leaf of brinjal by leaf hopper. And you can go through this table, you can read what are the different diseases and what are the vectors of those diseases. Carrot yellow is transmitted by 6-spotted leaf hopper. Dactyl wilt of cucumber transmitted by striped cucumber beetle. And the bud necrosis of watermelon transmitted by thrips. Tomato spotted wilt virus by thrips. Turnip mosaic virus by flea beetle, and purple top wilt of potato by aster leaf hopper. You can go through this table, this is also important. Some are seed-borne diseases: I don't know how much this tomato and lettuce mosaic virus transfer proceed, but in some books it has given there is some chances of transfer of these viral diseases to seed. But black tomato and Haemophilus blight of seed borne diseases, black tomato and black leg of crucifix, and Haemophilus blight of brinjal. The seed treatment with hot water at 50 degrees centigrade for 30 minutes we have to do to prevent this seed borne diseases. And serious diseases during seed production, Patulach of onion, Haemophilus blight of brinjal, and Pseudomonas of cabbage and cauliflower, carrot, lygus bug, this is insect. Carrot lygus bug is insect. These are the serious problems during seed production of the crops. And here, if you see any objective book like instant horticulture and anything, in the first they have given classification of vegetables based on various characters. That is very important. You have to by heart all the classification things, because a lot of questions will come from the classification only. Monocots and dicots. The crops belong to the families RAC, Iliaceae, Liliaceae, Diosporiaceae, or monocots. And the crops belong to other families are dicots. They may ask which one of the following is a monocot vegetable like that. Tender, all warm season vegetables are tender, and all cool season vegetables are hardy. And based on the rate of respiration, onion and potato they have less respiration rate, and leafy vegetables and broccoli they have high respiration rate. The question will be also like this: high shelf life. Because of the low respiration rate, onion and potato have high shelf life. Because of the high respiration rate, leafy vegetables and broccoli they have less shelf life. And Protandry, Umbellifera family, onion and carrot, they have Protandry, Protogyne, coal crops, and elephant cookium, tapioca, chippermanis have Protogyne, Hydrostatin, brinjal, lectogramine, lima bean, leistogramine, pea and French bean, chasmogamine, tomato and capsicum. What are the different genetic instability, cytoplasmic instability, ingredient depression, high, medium, low, high ingredient depression in carrot, medium in onion and coal crops, low in cucumber beets, and anthesis, time of the flower opening, bottle gourd, ridge gourd, snake gourd, flower opening in the evening, and climacteric and non-climacteric, tomato, muskmelon, watermelon, climacteric, others are non-climacteric. So in any objective book, in the beginning there is a classification like this. So you go through the classification, that is very important. A good number of questions come from this classification.